Good afternoon and welcome to everyone. It's a nice day where I'm sitting in sunny Taunton down in Britain. One of our speakers today is sitting, I understand, in a sunny Sweden. So Stockholm is a nice day as well. So we're going to be using Slido today, as many of you are probably well used to doing. So if you have not used it before, you can get into Slido two ways. One is by going to the QR code, which you'll find on the right-hand side of your screen, or you can go to slido.com and enter the code, which is #LM040322. So if you'd like to do that, what we'll do is we'll get underway. So today we're going to be using Slido in three ways. The first is for this opening poll, and what we're going to do is take the poll and then we'll go through the answers. I'll then hand over to Mark and Carl, who will host today's presentation. And then if you have any questions during the talk or afterwards, please use Slido for Q&A. And at the end, we'll ask you for some feedback like we normally do. So Abraham, let's put the poll up and let's get going. Okay. So some of you have probably already started to take it as it's live. So let's look at the first question. What is AI? So you have four choices here. So Abraham, can we put up the four choices? When robots shut down automatically, technology that performs tasks that normally a human would, discovering a technology for the first time, none of the above. So if you'd like to make your choice, thanks very much. We'll move on to question 2. Which of these is not an AI technology? Facial recognition, image recognition, robotics, and animation. Interesting choice. Okay, question 3, which one of these is not machine learning? Artificial intelligence, machine learning, data statistics, and deep learning. Which one of these is not machine learning? Okay, question 4. Now we've got to fit in the word here. XXX algorithms enable computers to learn from data and even improve themselves without being explicitly programmed. Be careful not to give my answer away here to show my poor depth of knowledge. Okay, the last question, please. Pick which one of these is not an example of AI in construction. Oh, I think I might have the answer. Okay, thanks very much. What we'll do is just give you a moment or two to answer. And we'll now, Abraham, we'll go back to the beginning and we'll run through the answers. Okay, so let's have a look. So 10 people have kindly filled it in. If you carry on filling it in, the statistics will change as we go along. So what is AI? Technology that performs tasks that normally a human would. Now, Mark or Carl, do you want to mark us here? Have people got it right?
Well, that's a very good question. I think I'd go with option B myself.
Yeah, well, that's what people have gone with, 85%.
Yes.
So none of the above was 15%. So there's some people who hopefully will learn a bit more today.
I will put in D there, actually. Because yeah.
Okay, so we're going to have an interesting discussion later then. Okay, so the next question, which of these is not an AI technology? 85% have gone for D, animation. Is that the right answer? Mark, Carl?
Animation is not an AI technology. However, I'm also sympathetic to those who say that robotics is not an AI technology. AI can be used in conjunction with robotics, in my view, but robotics is not necessarily AI. So it looks to me like everyone's right on this one.
Ah, right, great. Okay, so there's some good knowledge in the room. Okay, let's have a look at number 3. Oh, what one of these is not machine learning? Oh, right, now we've got a bit of a spread round here. So data statistics come out with 43%, but so does deep learning. Everyone's got an answer here, so I'm going to have to defer to you, Mark or Carl, to see which one of the.
I think I'm going to let Carl take this one.
I would say C.
So you think AI is not machine learning?
No, sorry, AI is not data statistics.
Oh, sorry, I got it wrong. Data statistics is not machine learning. Yeah.
No, that's just showing the numbers.
Yeah, that's what I thought. So I'm giving my answer away there. But yeah. Okay, interesting. Question 4. Right, which of these algorithms enable the computers to learn? So artificial intelligence comes out on top at 57%. Mark?
Well, this is a very interesting one, because I'm not convinced I know the answer to this one. I would have said deep learning, actually, but I'm not sure that I'm correct on that.
All I can say is I do understand from my simple things that machines can learn off each other. So am I right in that?
Yeah, I should say B as well, deep learning, because we are trying to replicate some of the nerve systems in the brain when you talk about deep learning, to be more intelligent all the time, retrain and so on.
Yeah. The precise meaning of a lot of these things is quite tricky, and it's probably not important for most of this audience to understand the differences between these things in order to get some benefit from the later presentation. And certainly, what is artificial intelligence is a pub discussion over beer, as much as anything else, because it's a very wide catch-all that's used in all sorts of different ways by people who want to sell you things. So I think we'll have a look at some sort of practical examples of that later on. And machine learning, by the way, is no more than curve fitting. It's the mathematics of fitting a hypothesis to data. So it's just maths.
Yeah, and I'd certainly like to have the discussion over a beer, but never mind. 5, pick which one of these is not an example of AI in construction. Well, interesting, 93% have gone for wedding planning. I think that might be the right answer. Is that correct?
I think the other 7% were being humorous in this case.
Well, I actually think it's quite a humorous sort of question. So thanks very much for that. I hope it's given you a sort of flavour for the audience. So what I'm going to do is I'm going to step back, remind people, if you have any questions for Mark and Carl, please do put it into the Q&A on Slido, which means it's all in one place. If you think it's a cracking question, you can vote for it. And if there's more than 2 or 3 questions, it will come up above those. So thanks very much. So I'm going to hand over to Mark, who I think is going to start us off, and he'll then introduce both himself and Carl. So over to you then, Mark.
Thanks very much, Howard. So I'm just going to spend a couple of minutes explaining who Carl and I are, and in fact, next slide, please, Carl. Explaining who Carl and I are and why we're talking to you here. Next slide again, please. So I'm Mark Crown. I'm the managing director of Nexa Insight here in the UK. A little bit more in a moment about who Nexa Insight are and what we do. Carl, do you want to introduce yourself briefly?
Yeah, sure. I'm Carl Stenstedt, based in Sweden, Stockholm. Worked in the IT business for 20 years, and one of the co-founders of Nexa Insight since 4 years ago.
Wonderful. Next slide, please. So the agenda that we're going to cover today, we're going to focus after this initial couple of minutes on real world examples of AI and Internet of Things being applied in construction and in use cases that are adjacent. And there will be some time for Q&A at the end, as Howard has mentioned. Next slide, please. So a lot of words on this slide. What does that add up to? It adds up to the fact that Nexa Insight is about applying complex and powerful technology to solving real-world business problems. And we'll look at some of the industries that we work in just a moment. In terms of where we are, we're a Swedish HQ'd firm. There are about 2,000 people in Nexa Group worldwide. We are principally a Microsoft partner, and we're a type of organization called a systems integrator, right? So we don't sell products to people to do things. We build systems that help people to do those things. Now, we often build quite similar systems for different organizations. So we have a lot of learning that we bring to those projects, but we are not a product company. We do not sell products. Within within the area that we work very closely with Microsoft. We are one of their top partners at doing the kinds of things that we're going to talk about in a moment in Europe. And we work with Microsoft's clients on some of the most complicated use cases. So next slide, please, Carl. These are the 4 principal industries that we focus in. Obviously, we're going to be talking primarily today about construction, but the things that all of these industries have in common is that they are real people doing work away from desks and away from computer screens, and they involve the collection of information from devices in the field and making use of that data. Next slide, please, Carl. So there are a number of solution areas that we commonly work in, and this sets those out. Connected products, any kind of device that needs to connect to the cloud and upload data. All applications to do with computer vision. And what does computer vision mean? It means using AI and machine learning to extract meaning from digital images and allow people to take action. We've got some very specific examples on that in a minute. Modern data platform is the IT infrastructure that you need to put in place to do something useful with all of these data. And then the last 2 are specific use cases where we combine that technology. And we'll spend the rest of this presentation talking about the last one, which is Construction 4.0. Next slide, please, Carl. Okay, so it's over to you, Carl, now to set out some of these real-world examples.
Okay, I'm experiencing some network problems. Can you hear me correct right now? Because I can't hear you so good. Can you hear me?
Yes, you're back.
Okay,
you're back.
so,
we can hear you.
Okay, and then it's to tell me if you can't hear me, because it's a red dot here in network error, so that's not good. So we started this journey a few years ago with NCC. Is one of the biggest construction companies here in the Nordics. And they are like in the big times regarding the technology and so on to be data driven on a construction site. So this to start about safety on the construction site, to start something to be data driven. So the first project that we did, and there is also a reference movie on YouTube that I can share afterwards, that we took 2 standard cameras that you see here in this picture. Dumb cameras, no intelligence, but very good cameras. Mounting them on the crane. And the use case at first was to reduce number of accidents underneath the crane when it did some heavy lifting. Because it's a lot of casualties the last 10 years. And if something happens on a building site or a construction site in Sweden, everything shuts down. So it's also about money, because they need to have a briefing, what happened and so on. So the case was about to give the crane operator some new tools to understand what's happening underneath. So if you look at the picture on the right, it's that the AI working on to detect people that are in risk zones underneath the crane, and also to find people because you're 60 meters up. So that's the type of view that we could help the crane operator with. So we train a model and deploy it into the crane. And that was the first use case in the construction industry here in Sweden, also I think Europe, around computer vision and so on. But the problem is that NCC doesn't own the crane. They doesn't own it and it doesn't produce it. So they wanted to highlight the things that they needed. And the first case about safety, of course. So that's the one of the cases. More about safety, because as I said, NCC doesn't own the crane, but they rent a lot of stuff. So this is, for example, Cramo, who's a big rental to NCC Group, all type of materials, including this type of system that for Cramo, that are one type of ingest to the construction site. So then they must share the data. So this is actually me during COVID training the AI model. And what we're doing in this particular case is that we look that I have the helmet on, the safety glasses on, the strap underneath the helmet, and also the safety vest on to be compliant to enter the construction site. So this is a full-scale solution that are on 10 construction sites right now around the Nordics to be compliant. And to be very clear about this is not about people tracking. We don't save any data. What we do is that we listen on a camera stream live and look at 4 things, and you get thumbs up or thumbs down that are compliant. So we don't save any data that Carl hasn't got the helmet on or something, just to be able to have some data around how many people are entering the site without a helmet, for example, and we don't save any data. So I can be honest about this. We took a few months with the union to have discussions around this until we released the product together with NCC and Cramo. So this is also one type of ingest to a data platform or digital twin that I will talk about later. So we have different sources. So this is 2 examples of computer vision, AI that are ingest to a platform. So we don't save any pictures, no names, just numbers in this case. More sites. So this is one of the, when they crush stones somewhere, mobile around a construction site. And the thing is that NCC, for I think it was 3 years ago, they said that we don't need any personnel on site that takes care of the trucks going in and out, so we can do it digitally. Just so when the truck comes into the site, you have 2 choices. I have small rocks or I have a big rock. That's to be honest about. Choice 1 or 2. The problem is that if you have a very big rock, you need to pay about 300 euros to leave the rock there. And if you got small rocks, you get paid the same amount. And so what we did to train a model to detect, are people honest around this type of rocks, to see that people are actually, NCC is actually losing money because they are paying people things that they need to handle and take down into smaller rocks, for example. So this is also one simple use case that are business driven and to be understand on a big construction site. Regarding computer vision and so on, you can also work with heat maps, for example. Heat maps is old historic data. And if you look at these 2 pictures, for example, you can divide the picture into 2. So you can separate trucks and people. So if you see at this type of site, for example, in the middle here, left in the middle, you have a lot of trucks entering the site at the time. And I'm not sure if you can see because my picture is around it, but people is also doing some work around this type of site where trucks are moving. So that's also about risk and get an understanding of the construction site right now, and to work with safety. For example, here on the right, this is a no-go zone. And in this case, people went out smoking in a no-go zone when a lot of heavy lifting went on. So that's also not about finding Carl that go out and smokes. It's about working with safety and to talk about where you should take your smoke and so on. So that's how we can use the same data in a historic way and understand what's happening on a construction site. That's called heat maps. Also, one type of data ingest for a platform to be data-driven. So I'm talking platform. So some of these pictures that I've seen here is from a construction site for a school south of Stockholm. So in this project, we ingested a lot of data, for example, computer vision, the helmet and so on, and also some other type of IoT sensors into a digital twin during the construction. So we had trackers from the helmet on the construction workers. We had type of detectors that look for microscopic dust, for example, that are very, very dangerous. We could shot off different zones when there are microscopic dust. And we can also track, for example, decibel, temperature, and so on during the construction. And the model that you see here is from the architect that constructed and took from the blueprints for the school. So we could do in real time look at the school during the construction. And it was very, very successful school that they built, and right on time, actually. But the most interesting case around the digital twin is that after the school was finished and they start to have children running around here, they use the same technology for the school. You can look at air quality, you can look at how much sound are there in different areas. You can also use the same technology as me at the helmet, for example, to detect if the children having their cycle helmet on them when they ride to school. You can also work with heat map to find different zones that are risky. For example, when the children entering the school and parents park in a no parking zone, for example, that are dangerous. So you can work with the same technology even after the construction. So this is a good public reference case that we have here in Sweden around digital twin and school and NCC. So now we can talk about mining, because there's also a type of construction site. So we have done a lot of different computer vision type of cases in the construction industry here in the Nordics. They're also a little bit left behind, but they need to be data driven. And even in this case, we started about environment. So in these two pictures down the right, it's water running. And if you get some kind of sand and so on into the water, it should be clear water, like in the picture left. It could be that something dangerous is going on. It can in some way destroy the pump, for example, and it can be very dangerous for the environment if this function stops. So in this picture, we use cameras to look at the water flow and train models to understand what will happen if something happens with the type of sand in the water in this picture. So when you have a mine, you have a lot of waste coming up from the ground, like 2 kilometers down, and you mix the waste with warm water and pump it up to an artificial lake, a very big one, like you see in the pictures on the right. And of course, you treat the water before you let it out into the nature again. But of course, it will leak, so you need to pump it up again. And that type of wheel that you see here with the pumps is that we 24/7 monitor with our computer vision solutions. So we use standard cameras, we use edge compute, and we actually have a connection up to the steering system to the mine that are built by ABB, for example. So it's in production and in a Swedish mine. So it's a simple technology. It's a small project, but it's very good for the environment, because before that, people had to go around with a car 3 or 4 times a day, look at the water, or, for example, look at this picture for 24/7. And it's so boring that you will fall asleep. So that's not good either. And so this is a simple solution that are very helpful for the mining companies. And we have more examples. So when you dig up the mine and you transport the type of stones into crushers around the mine, there are also people sitting and looking at this conveyor belt with stones, and they need to be able to stop the conveyor belt if they find a too big of a rock, and put a robot arm to take it out. But of course, they miss it sometimes. So we have actually used the same model as the NASA had when they landed on Mars last year, because you have a 20 minutes radio silence. When the NASA lander need to navigate and find a landing spot on Mars for 20 minutes. And it's open source, so we take that algorithm and retrain it to use on the mining industry, actually, together with Chalmers. So now we have a model that can detect too big of rocks to help and support the operator, so we can take off the rocks. Because if we don't do it, it could be stuck somewhere in the crushing machine, and you need to stop everything for a few hours. It's very riskful, and you need to actually try to take it out somewhere. And it's not fun, it's very costly with this type of stops. We also have more technology in the mining industry. This, for example, is on an open mine in north of Sweden. And I can't even explain how complicated it is, but we have sold it. We have a camera that looks at some type of mud floating down, and we need to calculate how much is floating every second. So that's the type of stuff that we use, and this type of use cases that the mining industry needs. So also, again, a lot of different use cases that we need to solve together with the customer to become digital. So, and one of the biggest sites that we have is a global shipping company. This is a site in the US. And maybe the same thing as in the construction industry, people getting hurt by trucks, forklifts, and so on. So in this particular site, we have about 50 different cameras, an old installed base. We don't need any new cameras. We took away the cameras in the lunchroom and so on, just 50 cameras outside this big, very big terminal. And the use case is this, that if you are not an employee of the shipping company, that you run as a truck driver goes into the area and pick up a container, you are not allowed to leave the truck in no way, because people getting killed all the time around the world in these type of terminals. So we use 4 edge compute devices and trained an algorithm to detect when people open the door and take a step out. And then automatically we send out an alarm to a guard that goes out to the right zone. And also we get an automatic ticket to the truck driver with a bill, and also an instruction that he or she are not allowed to enter the site in, I think it's about 1 week or so. So they also get some punishment, so they learn. And it actually is scaling worldwide right now. I think the solution is out for 20 terminals worldwide in different locations. This is in US, we have it in Morocco and so on. So it really works, even though it's different geographical situations with sandstorms and snowstorms and so on. So this is one type of solutions that are also in production and used worldwide. So custom IP for our customer. The same company have more different use cases. It's a lack of containers worldwide, and they don't trust the cleaning companies or repair service companies that fix the containers. So when the cleaning company comes in, you take a picture outside and inside the container to get a better understanding what type of service do we need. For example, if you transport bananas over the sea, you must change the floor afterwards, and so on. So a lot of different use cases that we use AI technology and machine learning to get understanding what type of fleet of containers do we have, and what type of service do they need to do with the containers. So overall, it's the same technology, even it's mining or shipping and so on, and also the construction industry. So we are here to inspire you what you can do. This is not, as Mark said, our product. We build our custom IoT solutions or AI solutions for our customers. We build their own IP together with them. So that's all for me, Mark. Now it's your turn, I think. That was the last slide.
Excellent. Howard, are you going to start the question and answer session off? And I'll take the questions initially, and I'll pass them over to Carl if I think he's better placed to answer them than I am.
Sure. Would you like to stop sharing your screen, and then we can bring the questions up on the screen so that, yep. Okay. So Abraham, do you want to put the first question we have up on Slido? So here we go, Mark. Have you had difficulty in using this on high security construction sites, for example, nuclear power plants?
Okay, well, sorry, Carl, did you want to answer that?
No, you
okay, sorry, I thought you were okay. So the simplest level of answer to this is, to the best of my knowledge, we have not yet done a project like this on a nuclear power plant, although we have a number of discussions going on that might lead us to deploy some of this technology here. I'd love to be able to unpack this question a little bit with the questioner. Maybe they could ask some supplementary questions. What do they actually mean by difficulty in this case? Because that could mean quite a lot of different things. Are you asking if the cameras are radiation hardened, or are you asking whether there are particular issues around the recording of this kind of data in that plant? I'd be reluctant to speculate further and try and answer those questions. But if maybe there's something more specific, then ask. Otherwise, please feel free to email me afterwards, and I can take the question.
I can also fill in there that everything that I've shown you is doable totally offline. But it's easier if you have an internet connection. I actually worked with nuclear power plants before in my life, so I know how difficult it is, because I don't want to have an internet connection into the nuclear power plant. No way, as a citizen. And the thing is that the models that we have shown, if you have a camera stream, you have a lot of pictures that you train a model with, and we use the cloud to train the model, because we need a lot of compute power for a short time, and then we deploy it on edge. So the edge compute just listen to it. So it's no problem to do it on site on a nuclear power line offline. No problem at all. They have the same thing in the airports and so on. They are not even allowed to have the connection outside. But sometimes you use microservices into the cloud as a hybrid version. Of course, it's easier to do it, but there's no problem to work in defense or in the power plant.
Okay, thanks very much. Can we have the next one, please? Do you have a business case for each of the applications demonstrated?
Do we have a business case? Well, the business case is owned by the customer in that in each particular case. We help customers with their business cases. I suspect what might be lying behind this question is the idea that it must be hugely expensive to do all of these sorts of things. And I guess if you go back 10 years, it was very expensive to do this kind of thing. What has really changed is the creation of public cloud infrastructure by Microsoft and AWS and Google, and the creation of sets of tools for building AI and machine learning applications that make it very cheap, or relatively cheap and quick to do that. So, for example, the production version of the ports example that we were looking at earlier, that cost in the order of hundreds of thousands of dollars in that particular case. But the business case there was somebody getting killed in a container port terminal costs the container port terminal operator at least $1 million, even if it's not their fault. Just the process of dealing with all of that and the cost of paying the lawyers to defend their situation and all of that kind of thing. So the business case for each application is not a fixed thing. It depends on the business requirements of the client that is applying it. I hope that doesn't sound like a weaselly answer.
No, I think what someone's looking at is return on investment, I think is what's being put in the chat here.
Well, yeah, none of this gets done unless there's a return on investment, obviously, because this is people paying us to build these solutions for them because they have a specific business problem that is costing them money.
Yeah.
That's the thing.
Okay, let's take the next question. In your examples, where is the video stored? How does this fit with data protection legislation regarding personally identifiable information? I suppose that means a face, does it?
The thing is that the video isn't stored anywhere. It's a live stream that you look at as an AI, and then report numbers up to a BI dashboard or something, or a system. So that's the thing. We don't store it.
In fact, in these examples, the video never leaves the site. So for example, the crane example that Carl was talking about earlier on, there is a computing appliance, a server, if you like, that's installed in the crane itself. The video is routed to that computing appliance, and all that goes out from that computing appliance is what the system has learned from watching that video. That is, there are some people underneath the crane and there is a vehicle, and that information goes to the crane driver. No video ever gets stored or leaves the site.
Okay, thank you. Let's have the next question then. In addition to health and safety, have you considered monitoring quality aspects? Temperature and or humidity present prior to application of finishes, for instance?
Absolutely. Now we've majored in this presentation on artificial intelligence and specifically computer vision, but right up at the beginning I mentioned that one of our key areas of expertise is the Internet of Things, and these are primary examples of the application of the Internet of Things. In this case, a thing might be the temperature sensor and the humidity sensor that you have in your production process, and our systems then capture that data and store it and make it available subsequently for machine learning algorithms to look at. I mean, what do we have time for a couple of minutes anecdote on this particular one, do you think?
Yeah, we've got a few more questions, but as long as you don't go.
Okay, well, I'll keep it quick, because there's a good example of where temperature was relevant in one of our clients. So in this case, it was a manufacturing client. They had a problem where one of their production lines would very, very occasionally go wrong, and they could not work out what the problem was. They tried for a very long time to work it out, and they'd had human beings poring all over the data, and the production engineers looking at this couldn't figure it out. In the end, what they did is they asked us to perform what's called a machine learning experiment, to look across all of the data and see whether we could find some correlations with failures and some of that data. And the interesting correlation that we found, actually in that case, was with temperature. We found that the machine failures always happened on days where the external temperature, and this is, for example, weather data that we're taking from the weather forecasters, where the external temperature was very low. Then with that, armed with that information, the production engineers quite quickly figured out that the problem was one of the machines going out of tolerance in low temperature. And the fix in that particular case was very low tech. On cold days, they simply pointed a hot air blower at that particular machine. No more problem.
Okay, thanks very much. Let's have a look at the next question, because I think you may have covered this, but I'm not sure. What types of safety use cases have Nexa Insight looked at for computer vision?
Well, we have covered some of those on this presentation. So there was the there was the overhead lifting case, where we were looking to build effectively digital safety barriers around the people underneath. There was the protective equipment case, the people coming into the site are wearing the correct protective equipment. In addition to that, and actually the ports example was a vehicle and people deconfliction case, which is obviously something that also is a major consideration for construction construction sites. So I think one of the things to understand about this, and this comes back to us being a systems integrator, is what we're actually building here is a platform that you can run effectively multiple safety use case applications on. So the analogy, if you like, is you don't buy lots of different systems that do lots of different things. You buy, like a desktop computer, you buy one system and have that system do a lot of different things, and those things can evolve over time. So you can think of what we've been describing as a platform for running multiple safety use cases on a particular site.
Okay, thanks. I've got a question that's come up. I'm going to just take that's come up in the chat. It's Gabrielle has asked, did you use any of AI technologies to manage COVID-19 vaccine rollout?
Carl, do you want to take that one?
Yeah. Nexa Insight has built the system to all the booking stations around the COVID vaccine here in Sweden. For all major cities to use, because it's very complex in Sweden. You have a lot of different places when they provide COVID vaccines, and all the booking systems down with everyone in Sweden at the same time to book a time. So we built the whole platform together with Microsoft as a big reference here in Sweden to have all the transport, logistics, and also the booking system for COVID-19. That's a short answer, but yes.
Okay, thanks very much. Clearly wasn't used in the UK then, Mark, as far as you know.
I don't think we did anything on that in the UK. No, there were other consulting firms that used this kind of technology to do those kinds of things.
Here, we get down a bit of heat mapping here. How does the technology work on multi-story buildings in terms of heat maps, etc.? Is it simply sensors required on every floor?
Yes.
Interesting, very quick answer to that one. If they were all so simple, eh?
I wanted to prove that I could be brief sometimes.
Oh, great. Can the technology be used for monitoring progress, maybe compared to a BIM at any given date in the program?
Yes, absolutely, and we are in discussion with a number of firms about doing exactly this, and I'm sure that what's underlying the question is that more and more firms involved with large construction projects are wanting to move towards a situation where effectively they have a sort of a control room kind of situation where they can surface all of the data around construction and have key people come together to actually in advance figure out the sequencing of operations and that kind of thing. And the kind of technology that we have talked about here in terms of using computer vision to extract meaning is key for that, because then you can effectively walk around the site with cameras on, and you can pick up some of the information about progress, that kind of thing. So yes, we're working with a number of these kinds of use cases.
Okay, thank you. I think we'll go to the next question. I'm not quite sure whether this is an answer to a previous one. It says recording of data and surveillance. I think it might be referring to a previous question.
Yeah. Just to be clear about that, the only time that you have some recorded data is when you train the model. You need to have some data to train the model. After that, you throw that data away, and you have a model that just listening in real time live on a camera stream that doesn't store any type of data or personal information at all, and just report numbers, number of helmets, for example.
It might be worth just briefly talking about what do we mean by data to train a model. So the ports example that we saw before required a machine learning algorithm that could recognize people from a long way away and trucks. So what we mean by training the model is that you have to collect together a significant number of examples of video showing people and trucks. And then you take the model through each one of those examples and you say, here's a person, here's a truck, here's a person, here's a truck. And the model then starts to learn how to recognize a person in that particular case based on the human being who has told the model what some example information means. I hope that was useful, but this is a very common thing about training AI machine learning. You need representative data, representative information in order to train the model. And actually the collection and cataloging of that representative information is often one of the main tasks involved in building this kind of solution.
Okay, I've got one more question, I think. Are any of the existing use cases, i.e. the PPE application, available off the shelf following development, or is each application developed from scratch?
So I think, Carl, that the personal protective equipment example, which was with Cramo, I think Cramo rent that now, don't they?
Yeah.
Yeah.
And also around that, because it's not, you don't need to invent the wheel all the time. Also, there are things that you can learn from the internet, for example, how to track people. You get the common knowledge around it, and sometimes you use standard microservices into the cloud that you already have the energy up and running in the cloud. So it's a mix. But not to scare you off. It's easy to get this type of things in place. We have done it before. Sometimes it takes about 1,000 hours. It could take, some of the cases here is like 140 hours, for example. So
yeah, I think that's the point. So the either or that's implied in the question isn't quite right, because most of these things are not available from us off the shelf, but we very much don't start from scratch each time, because we've got all of the experience that we've built up in these kinds of use cases, and also in how to best use the technology most quickly to deliver for those use cases. So that's our expertise as a systems integrator. We can probably do something 10 times as fast with the same technology as somebody else who was doing it for the first time would take.
Okay, I don't think, do we have any more questions here, Abraham? Now, what we do have, though, is perhaps we could ask people to start to look at the feedback questionnaire. That is now available. So if you'd like to please complete that, be useful. Oh, it looks like we have one more. Are you developing social distance monitors for the next COVID outbreak? We hope we don't have another one, which I suppose is the next unknown pandemic.
I'm not sure of an example that we're actually working on there at the moment. Do you know of one, Carl?
No, but it would be very easy.
Yes, that was going to be my answer as well.
I'm not that I'm a construction expert, but I have seen these actually being used, the little wristbands, so that when you can detect how people are getting close to each other and that sort of thing. So I'm no doubt they're just very simple monitors that go into the standard system.
Yes.
Okay, well, thanks very much. I mean, I'm fascinated because obviously I've give my hand away that we were having a conversation beforehand saying that the construction sector is a particularly slow sector to change. So where would you say we were in the UK, Mark, with adopting technology into construction? Very much the early days, getting into the sort of middle, or is there still a long way to go?
I think it's very early days here. I would say that in general, the Nordics tend to be somewhat ahead of us in applying this kind of technology. As a nation, we're far from the slowest. We are actually quite innovative, but not as innovative as the Nordics, which is one of the reasons why it's really interesting to look at the practical examples that are being used in that marketplace, because what's practical there, the construction in the Nordics is fundamentally, I would argue, no different to construction in the UK. So if something's practical and makes business sense there, then it's probably practical and it makes business sense here too.
I just wondered whether, I mean, one of the historic things that people always use as a reason is the very low margin that construction works on in this country. Are margins better in Nordic countries or in Europe than we have here? Because that is one of the things that people always use as an excuse. Oh, it costs money.
I don't feel qualified to answer that question because I don't know what the construction margins in the Nordics are.
Okay, I won't put Carl on the spot.
I think there are very good margins both in Sweden right now. But
okay, the margins are much better, are they? Yeah. Okay.
Because I mean that boom.
Yeah. Well, we have building booms here, but that doesn't necessarily translate to margins widening. I think the interesting thing is obviously learning, and I think today is quite interesting, is to begin to learn from what other nations are doing. Because otherwise we work in a vacuum. So thanks very much, Carl, for your insights, and thanks very much, Mark, for also taking the British perspective and both for answering the questions. So Abraham, do we have a slide for next week's? So next week, no, that's today. Next week, we're going to be looking at insurance-backed alliancing, the IPI model. So for those of you who are interested in that, please register straight away. And for those of you who are interested in CPD, you can get a digital certificate through MP MyProPass. To create your free account, store all our certificates in one single place, please visit www.mypropass.co.uk. So many thanks to everyone for participating today. And can I say thank you once again to Mark and to Carl, and can I wish you all a great weekend. So many thanks. Goodbye.
Thank you.
Thanks, everyone.
Thank you.